Welcome back to Database Internals Crashcasts. I'm Sheila, and I'm here with Victor to dive into another exciting topic in our Introduction to Databases season. Before we begin, I'd like to remind our listeners to rate our podcast on whatever platform you're listening to us. Your feedback helps us improve and reach more database enthusiasts like you.
That's right, Sheila. We truly appreciate our listeners' support. Today, we're continuing our journey through the data modeling chapter, and we'll be exploring entity relationship modeling, or ER modeling for short. This is a crucial concept in database design that helps us visualize and structure our data before implementation.
Absolutely, Victor. But before we dive in, I have a fun quiz question for our listeners. Picture this. You're designing a database for a library. Using ER modeling, how would you represent the relationship between books and authors, considering that a book can have multiple authors and an author can write multiple books?
Oh, that's an intriguing question, Sheila. It really makes you think about the complexities of real-world relationships in data modeling. I'm sure our listeners will find it challenging yet relevant to our topic. Let's give them some time to ponder while we break down the concept of ER modeling.
Great idea. Let's start with the basics. Victor, could you explain what exactly ER modeling is and why it's important in database design?
Certainly, Sheila. Entity relationship modeling is a conceptual approach to describing data and their relationships in a high-level, abstract way. It's like creating a blueprint for your database before you start building it. The primary purpose of ER modeling is to provide a clear, easily understandable representation of the data structure, which can be used by both technical and non-technical stakeholders.
That makes sense. So it's like planning the layout of a house before actually constructing it, right? You want to make sure everything fits together properly before you start hammering nails.
That's an excellent analogy, Sheila. Just like how a house blueprint shows rooms and their connections, an ER model shows data entities and how they relate to each other. Now let's break down the key components of an ER model: entities, attributes, and relationships.
I've heard those terms before, but I'm not entirely sure what they mean in this context. Could you explain them, Victor?
Of course. Let's start with entities. An entity is a distinct object or concept in your system, something that you want to store information about. In our library example, book and author would be entities.
I see. So, attributes would be the specific pieces of information we want to store about each entity, right? Like the title and ISBN for a book, or the name and birth date for an author.
Exactly right, Sheila. Attributes are the properties or characteristics of an entity. Now the third component, relationships, describes how entities are connected to each other. In our library example, we'd have a relationship between book and author to show which authors wrote which books.
That makes sense. But I imagine it can get complicated when you have many entities with complex relationships. How do we manage that?
Great question. This is where we introduce concepts like cardinality and participation constraints. Cardinality defines how many instances of one entity can be associated with instances of another entity. For example, in our book-author relationship, we'd specify that a book can have one or many authors, and an author can write one or many books. This is often referred to as a many-to-many relationship.
I see. And what about participation constraints? That sounds important.
Indeed it is, Sheila. Participation constraints determine whether the existence of an entity depends on its relationship with another entity. For instance, in a library system, we might say that every book must have at least one author, total participation. But not every person in our database needs to be an author of a book, partial participation.
Wow, ER modeling seems to cover a lot of nuances in data relationships. Are there any common pitfalls or misconceptions that people should be aware of when creating ER models?
Absolutely, Sheila. One common mistake is overcomplicating the model by including too many details that might be better left for later stages of database design. Another pitfall is not properly identifying weak entities. These are entities that depend on the existence of another entity and can't be uniquely identified by their own attributes alone.
That's really helpful, Victor. Could you give us an example of a weak entity in our library scenario?
Sure thing. In a library system, a book copy could be considered a weak entity. It depends on the existence of a book entity and might be identified by a copy number that only makes sense in relation to a specific book. Without the book it belongs to, a book copy wouldn't have a meaningful existence in our database.
I see. That really helps clarify the concept. Now, I'm curious about how we actually represent all of this visually. Is there a standard way to draw ER diagrams?
Great question. Yes, there are standard notations for ER diagrams. Typically, entities are represented by rectangles, attributes by ovals, and relationships by diamond shapes. Lines connect these elements, with different line endings indicating cardinality. For example, a crow's foot notation at the end of a line indicates many, while a single line indicates one.
That sounds like it could get quite complex for large systems. Are there any best practices for creating clear and effective ER models?
Absolutely. Some key best practices include 1. Keep it simple and focused on the essential elements. 2. Use clear and consistent naming conventions. 3. Validate the model with stakeholders to ensure it accurately represents the system. 4. Consider future scalability when defining relationships. 5. Document any assumptions or business rules that influence the model. Remember, an ER model is a communication tool as much as it is a technical document.
Those are great tips, Victor. Now, I think it's time we reveal the answer to our quiz question. How would you represent the relationship between books and authors in our library database example?
Excellent. For our library example, we would represent books and authors as two separate entities, each with their own attributes. Then we'd create a many-to-many relationship between them, often implemented as an associative entity or junction table in the actual database. This allows us to accurately represent that a book can have multiple authors and an author can write multiple books.
Thank you, Victor. That wraps up our discussion on entity relationship modeling. To summarize the key points: 1. ER modeling is a conceptual approach to designing databases. 2. The main components are entities, attributes, and relationships. 3. Cardinality and participation constraints help define the nature of relationships. 4. ER diagrams use standard notations to visually represent the model. 5. Best practices include keeping the model simple, using clear naming conventions, and validating with stakeholders. Remember, a well-designed ER model is the foundation of a robust and efficient database system.
Absolutely, Sheila. ER modeling is a crucial skill for anyone working with databases. It helps clarify requirements, communicate design decisions, and set the stage for a successful database implementation. We hope our listeners found this episode helpful in their database journey.
Indeed. And to our wonderful listeners, we'd love to hear from you. Visit crashcasts.com to join our Discord community, where you can discuss this topic further and connect with other database enthusiasts. If you're enjoying our content, please consider supporting us on Patreon. Your support helps us continue producing high-quality, educational content. Don't forget to subscribe to the podcast and rate us on your preferred platform. Until next time, happy modeling.